Hey everybody, welcome back to Boot Camp. So now we're going to continue on our renal section, and we're going to talk about a very important physiologic system called the renin-angiotensin-aldosterone system. There's a lot to go over here, so if you guys are ready, then off we go. So this first video is just going to be a general overview of what is this system that we talk about when we say the RAS system and why is it important. So first let's think about what are the primary goals of the system. It's twofold. One of the goals is to regulate our blood pressure, and the other goal is to balance our fluid and our electrolytes. Remember, the basic principle of biology is this idea of homeostasis. It's not too much, it's not too little. We don't have too much volume, we don't have too little volume. Same with electrolytes, right? We don't want too much sodium and we don't want too low of sodium. It's all about maintaining that homeostatic state in the body. And this is one of the primary mechanisms that our body uses to do that, to maintain that homeostasis, is through this system. So the question is how? What is the primary mechanism that our body uses to help maintain this homeostatic state? I want to draw your attention to the bottom here and look at this structure that we've seen in the previous videos. And the importance of this structure is something called the JG apparatus. Remember, the JG apparatus is composed of three primary things. One of them is the macula densa, which is our key sensor for sodium chloride. The next thing is the juxtaglomerular cells themselves. And then there are also a third component called mesangial cells. But it's the JG cells that are particularly important for this RAS system we're talking about because these cells secrete something called renin. If we look at our primary activators of the RAS system, you can see that renin is secreted from either low blood pressure or low sodium chloride filtrate. So the macula densa cells can sense low sodium, causing the JG cells to secrete renin, or renin can be released if there's overall a sense decrease in blood pressure. To the primary mechanism of the system, we're saying, okay, renin is being secreted by the kidney via the JG cells, or the juxtaglomerular cells. It's really important to note here that renin is an enzyme, and enzymes are something that help a reaction occur. They typically help turn one molecule into another molecule. And the two molecules that are important here is the conversion of angiotensinogen into angiotensin 1. I want you to notice that angiotensinogen is a molecule that is coming from the liver. So this molecule is then undergoing a reaction with the enzyme renin to secrete angiotensin 1. And the second very important enzyme here that you guys have to know is this key enzyme of ACE, stands for angiotensin converting enzyme. This is an enzyme that is most commonly secreted from the lungs. However, there is a little bit of it that can be secreted from the kidneys, but it's very important for you all to keep this in mind because this is one of our primary targets of pharmacologic interventions with a medication called ACE inhibitors. We will talk much more about that in the pharmacology section, but here if you understand how ACE works, then you could think about what would happen, what processes would happen physiologically if we were to block that enzyme from doing its job. So if you turn your attention over here, you can see ACE, again, primarily coming from the lung, but not all of it. This is converting our angiotensin 1 into our angiotensin 2. In this molecule, angiotensin 2 has a bunch of very important effects downstream of the body. So it's very important to think about how this molecule is created in terms of what are the key enzymes and also what are the downstream effects, which we will talk about in the next video. So in summary, a good overview of the RAS system is that it has two key functions. It regulates blood pressure and it regulates electrolytes. Its primary mechanism involves two key enzymes, including renin and ACE, and the goal is to turn a molecule called angiotensinogen all the way to angiotensin 2. And 3, the primary activators, or the primary things that can cause a secretion of renin from the body, is a drop in blood pressure, which can be sensed by the renal baroreceptors in the afferent arteriole. Remember, the afferent arteriole is the side of blood that is going into the glomerulus, into Bowman's capsule, whereas the efferent arteriole is the side exiting. Another primary activator is a decreased sense of sodium chloride at the macula densa because this is indicative of a low sodium level in the body, and thus we will activate the RAS system because, as we will see, one of the primary effects of angiotensin 2 is to actually increase sodium reabsorption in the tubules. And the third one that's less commonly tested is that we can actually activate this system by increasing sympathetic tone through stimulation of the beta-1 receptors. And the beta-1 receptor is, again, something that can be targeted with pharmacologic interventions. So that's all I have for this one, just a quick overview of the RAS system. We'll dive a little bit more into the details in the next video.